Hello everyone. Today I'll be explaining the basic concept as well as engineering application of linear probabilistic modeling. Linear probabilistic modeling is taking a set of data and seeing if there's a positive or negative relationship between them. As you can see in this graph, there's a positive relationship between the x and y components. However, the line does not fit all the points exactly. The goal of the line is to minimize the distance between the estimated value and the actual value for all the observations. This is done by the methods of least squared. The two parameters, beta 1 and beta 0, should be familiar to everyone since they represent the slope and y-intercept of the graph respectively. However, there is another parameter which is the error of the line of regression. The error is a random variable which is normally distributed. It has an expected value of 0 and its variance is equal to the variance of the population. Since we know the variance and mean, we can find the probability of any point occurring. If we have x amount of inputs, then using the regression line and normal probability curve, we can calculate the probability of any y value. This is a very powerful tool in quality control because we can use linear probabilistic modeling to see whether a high number of defects is probable. Let's take an example where you're a quality control engineer for radar sensors. Your goal is to try to model the amount of defects with the amount of sensors in a linear way. This can be done with simple statistical analysis tools like Excel. In this example, the independent variable is the number of radar sensors and the dependent variable is the number of defectives. As you can see, the slope of the line is 0.0611. So for every one increase in x, the number of defects will go up by 0.0611. If your manager wanted there to be a 99% probability that given 2,000 radar sensors that 150 or less will be defective, you can use this model to determine if the quality is up to spec. If it doesn't meet the specifications, then you know that there would have to be some improvements to the quality of the sensors made. It's important to note that this line is inaccurate for very large or very small numbers as shown for the negative value of the y-intercept, so it's crucial to plan accordingly. In conclusion, I hope you have learned the basics about linear probabilistic modeling and know the power it has in engineering applications.